Hello everyone, welcome back to the channel. In today's video, we are going to talk about how to perform subnetting based on the network requirements. Subnetting is one of the most important networking skills, especially for network engineers, system administrator, and anyone participating for certification like CCNA or Network Plus. Instead of memorizing formula, we will focus on a practical step-by-step approach to design subnet based on real-world requirement. So let's get started. Welcome to CCNA 200-301, Implementing and Administering Cisco Solutions, Chapter number 55, How to Perform Subnetting Based on Network Requirements. Learn CCNA with iRush Academy. I have placed the complete CCNA playlist at the top right corner of the video information bar. In this chapter, you will learn how to do the subnetting based on the number of network requirements. So what are the basic requirements for subnetting? The point number one, you need to understand the basic IP addressing, such as what is an IP address, what is the subnet mask, and what is the default gateway. The point number two, you need to understand classes of IP address, and they are Class A IP address, Class B IP address, Class C IP address, Class D IP address, and Class E IP address. The point number three, you need to know the numbering conversion, such as binary to decimal conversion and decimal to binary conversion. So basically you need to know all of these concepts to perform a successful subnetting. So if you don't know about this concept, please watch the previous video in this playlist. There I explain everything about the IP addressing, classes of IP addressing, and numbering conversion. Watch those videos and understand the concept. Then come back to this tutorial. Welcome to the iRush Restaurant Group. You may be wondering why I brought the iRush Restaurant Group in this tutorial. This is to teach you how to perform a subnetting in a real-world scenario. So the iRush Restaurant is a group of restaurants and they have several branches around the world. And when you hear about the restaurant, the first thing coming into your mind is the kitchen. I agree, kitchen is the main part of the restaurant. They are used to prepare the food. Then there will be dining area to serve the food. But how these restaurant owners are tracking the sale, how they are calculating their profit, how they are managing their business, for that they need the support from the information technology, such as they need the computers, they need the printers, and of course they need the networks, and the communication need to be implemented between the branches to the headquarters to identify the business, and everything they need to track using the computer application. So even the business is restaurant, it is mandatory that they should have a network to provide the service. So that's why I took the iRush Restaurant Group into this tutorial. They have a head office and they have several branch office. All these branch office should be communicated or should be connected to the head office to track their daily activities. So in this scenario, just imagine you are a new network engineer that is recruited for iRush Restaurant, and your first task is implement a network in the branch offices and connect those into the head office. So the network architecture of iRush Restaurant provided you one IP address, which is 192.168.10.0/24, and he asked you to perform the subnetting and use this IP for all the 5 branches. So you need to do a subnetting. If you watch closely into this diagram, you can see the head office of the iRush Restaurant, and there are 5 branches, which are branch 1, branch 2, branch 3, branch 4, and branch 5. And the network designing team give you just one IP address with a Class C subnet. So the question is, where can you use this single network in these branches? Can you use this same single network at all branches? The answer is no, because they are all connecting to headquarters. So each branch should have a different network. Otherwise, network conflict can happen. You cannot provide the same network to branch 1 and branch 2, because these networks are advertised by the router, and when the router know there are same network available at multiple location, then it will confuse and it will affect the communication. So each branch of this should have different network. But here they provided you only a single class C network. So how can you use this single network at all branches? This is the beauty of subnetting. This single network you can divide into multiple subnetwork, and those subnetwork you can use at each branch. So here, how many subnetwork you needed? As you can see, there are 5 branches. So the number of subnetwork that you need is 5. So you need to divide the single network, which is 192.168.10.0, into 5 subnetwork. So I will show you how to perform the subnetting on this network. There are 3 important steps in the subnetting process. And what are those? The point number 1, convert the number of networks into binary. And the point number 2, reserve bits in the subnet mask and find your increment. And point number 3, use your increment to generate the network ranges. So these are the main 3 steps that is included in a subnetting process. So I will explain about each point and I will show you how to do that thing. For that, let's go to our network scenario. The point number 1 is convert the number of networks into the binary. So here, if you closely look at the diagram, you can see there are 5 branches available. So how many subnetwork you needed? I hope you already know the answer. So in the first point, what you need to do is, first you need to understand what is the total number of networks required. And when you look at the diagram, you can understand that total 5 branches there. So you need 5 subnetwork. The answer is 5. Then convert the number into the binary. You need to convert this number 5 into binary. And how to do that conversion? In the previous videos, I have explained how to perform a binary to decimal and decimal to binary conversion. So you can refer that video and get skilled in that process. Then come back to this tutorial. So to convert a decimal number into binary, you need to bring the conversion table. So this is the conversion table. So this is the number that we need to convert into binary. So in this table, first number is 128. So that has to be 0. The second one is 64. That also we can mention as 0. Third one is 32, 0. Fourth one is 16. That is also 0. Then the number is 8. That is 0. Then the number is 4. Yes, we can take it because to get the 5, we need the number 4. So that I will make it as 1. Then the next number is 2. So when we add number 2 along with the 4, we get the number 6. So that is not the number. We need only 5. So the 2 also should be 0. Then the last one, number 1, and that should be 1. So in this example, the number 4 and number 1, when we add, we get the number 5. So the conversion of the decimal number 5 is 101. So our answer is 101. When we convert the decimal number 5, we get the answer in binary 101. Now let's go to the point number 2. Reserve bits in the subnet mask and find your increment. So in this process, first you need to understand what is your subnet mask. So here the network is provided as 192.168.10.0/24. This is a class C subnet. So its subnet mask is 255.255.255.0. So this is our subnet mask. Now you need to reserve bits in the subnet mask and find your increment. For that, you need to convert your subnet mask into binary. So convert the subnet mask into binary and the answer you get as shown in the picture. Because you get the number 255 when all the 8 bits in a binary conversion table are 1. So wherever you see the decimal number 255, you can replace it with all ones. That means all the 8 bits should represent the number 1. And the decimal value 0 represents all the bits should be 0. Now reserve bits in the subnet mask and find your increment. So here what is the number of networks you needed? That is 5. And when you convert the 5, you get 101, right? So to get the 5 network, you need minimum 3 bits, right? So add that 3 bits into the network portion. So in this subnet mask, wherever the number 1 is available, it indicates the network part. And wherever the 0 is available, it indicates the host part. So if you want to get 5 network from here, then you need to move 3 bits from the host portion into the network portion. And from where you get these 3 bits, because to get the number 5 you need minimum 3 bits. So move that 3 bits into network portion, your subnet mask will be as shown in the picture. Correct? 3 bits from the host portion moved into network. That's why it is written as 1 instead of 0. Now what is the next step? Next step is convert this new subnet mask into decimal. So you get an answer 255.255.255.224. So how did you get this answer? It is very simple. The first part all contain 1. Okay, that we can written as 255. The second part also all contain 1. That also you can write as 255. The third part is also all contain 1. That you can mention as 255. Then this part you need to convert into decimal. Let me show you how to do that thing again. For that, again I need to use my binary to decimal conversion table. Here just distribute the bits in the table. So our value is 1 1 1 0 0 0 0 0. Now wherever the value 1, just add those together. So we have 128 here, so 128. Then we have 64 here, so plus 64, plus then we have 32 here, 32. And when you calculate all this together, you get 224, and that is the answer, this one. So when you convert this new subnet mask into decimal, you get this answer. So this is your new subnet mask you can use in your branch offices, that is 255.255.255.224. Now the next step is use your increment to generate the network ranges. So how to find out the increment? To find out the increment, go back to the binary version of your subnet mask, and this is the binary version of your subnet mask. In this binary version of subnet mask, identify the minimum bit position of your network part. So here this is the minimum value of bit position of my network part, and this is indicating the decimal value of 32. If you have any doubt, you can again use your binary to decimal conversion table. So I am going to write down the last part of the binary here, 1 1 1 0 0 0 0 0. And here you can see the last one. This is our increment, and it indicates the value of 32. So 32 is your increment. So here find out the increment value for the networks, and the answer is 32. And you need to use this value, this increment value, to generate the new network. So let me show you how to do that thing. So in the subnetting process, we have identified what is our subnet mask, which is 255.255.255.224. Then we also find out what is our network increment value, which is 32. Now let's generate our network by using this increment value. So let me show how to do that thing. For that, I am bringing one table which contains starting IP address and ending IP address of your network. And your first network start 192.168.10.0. This is the network provided to you for subnetting. So the first part is this one. Now what you need to do, you need to add the value of 32 to find out your next network. So add the number 32 to your host part, so you will get your next network as 192.168.10.32. Then again add 32 to the current network, you get your next network, that is 192.168.10.64. Again add 32, you get 192.168.10.96. Add 32 again, then you get 192.168.10.128. Add 32 again, you get 192.168.10.160. So all these are starting IP address of your network. And if you look at here, you can see the first one is 0. When you add 32, you get 32. Then when you add 32, 64, another 32, 96, another 32, 128, another 32, 160. So this is the starting IP address of your 5 network. Now you need to find the ending IP address of your network. And how to find out the ending IP address of network? Just perform -1 from the previous starting point of your network. So this is 32. When you do -1, you get the ending IP address of your previous network. Same like here. Here it is 64. Make it -1. So you will get ending IP address of previous network. Same applicable for 96, 128 and 160. Since this is the starting point of IP address, when you do a -1, you get the ending IP address of your previous network. So let's do that thing. So the first network ending IP address I got 192.168.10.31. And why the 31 came here? Because when you do -1 to the 32, you get the 31. And do the same for all the remaining network, then you get your ending IP address. So the second one is 192.168.10.63. Third one 192.168.10.95. Fourth one 192.168.10.127. And the fifth one 192.168.10.159. So we need 5 network. Our network requirement was 5. That's why we can stop it here because we already got 5 network. So when you look at this table, you can see 5 network which contain a starting IP address and which has an ending IP address. So you can use this network in your branch office as subnetwork. And another point I need to tell you, you got your network. Okay, and how many valid hosts you can have in that network? We know our network increment value is 32, but can I use the 32 IP address in that network? Let's see. The answer is you cannot use all the 32 IP address from that network. You know why? There is another concept I need to tell you, that is the network ID and broadcast ID. For each network, there is an IP address called network ID to identify that network. In the same way, there is another IP address which is called a broadcast ID. Except these two IP address, you can use all remaining IP address in your network. For example, in the first network 192.168.10.0, this IP address is the first IP address. This thing you cannot use in the real world network because this is considered as the network ID. This network ID used by the router to identify the network. And the last IP address 192.168.10.31, this one also you cannot use because this is considered as the broadcast ID. This IP is used to send the broadcast communication to the all devices in that network. So this also we cannot use. All the remaining IP address coming in between you can use in real world. So here the total number of IP address available in one network is 32. And when you remove the network ID and broadcast ID, which is 2 IP address, then you get 30 IP address as the valid IP address in that network that you can use for your devices. So what are the IP address you can use in your network? Let me create another table for that, which contain a starting IP address and ending IP address. And the first network is 192.168.10.1 because we eliminated the network ID which is 192.168.10.0. In the same way, when we remove all the network ID and broadcast ID from our subnetwork, then we get starting IP address of the second network as 192.168.10.33, third one 192.168.10.65, fourth one 192.168.10.97, fifth one 192.168.10.129. Then the ending IP address of the first network should be 192.168.10.30. The ending IP address of second network is 192.168.10.62. Third network is 192.168.10.94. Fourth network is 192.168.10.126. And the fifth network is 192.168.10.158. So if you look closely, you can understand that all the network ID from our subnetwork and all the broadcast ID from our subnetwork has been removed, and we only use the remaining IP address as the valid IP address in that network. So these are the IP address you can use for your devices in that network. Now let's come back to our Irish restaurant group, and here you can see the head office and 5 branch office. And you successfully completed the subnetting, and you have assigned the subnetwork to each branch successfully as a network administrator. And when you closely look up into one branch, you can see the subnetwork provided is 192.168.10.0/27. This 27 stands for 255.255.255.224, and this branch office network is starting from 192.168.10.0 to 192.168.10.31. But in real world, you can use the IP address starting from 192.168.10.1 to 192.168.10.30 because the network ID and broadcast ID we cannot use for the devices. So in this branch office, there may be a network router which you can provide the IP address of 192.168.10.1 as a default gateway. Then there may be a computer, there may be printer, there may be POS machine, there may be the CCTV camera, there may be the internal server hosted, and there may be the access point. So whatever the device is, you can use any IP address from the list as per your requirement. So in this chapter, you have learned how to do the subnetting based on the number of network requirements. Thank you very much for watching and subscribe to the channel for more videos. Enhance your skills using iRash Academy.